So now I'm going to go over to the model, and I've already run this analysis. So I think what I'll do is I will go over how I set it up. So the first thing I did is I grabbed the static structural here, and you can drag it over to the green box. So I've shown how to do that here, but I'm going to delete this. And then I have added my material properties, so I'll double click engineering data. And if you don't already have a material that you'd like to model, you can right click, go to engineering data sources, and click on your material library and click the plus button to add. But I've already added the materials that I want. And then next you can left click on geometry and then right click and go to edit geometry and design modeler. And I already have the model open. So what I've done is I've sketched two cylinders, and I've done quite a bit of slicing here. And I'll talk about why I did that. So I have the global coordinate system set at the center of the larger cylinder, and I've sketched the large cylinder about in the XY plane and the top cylinder in the XY plane. And I made sure that they're tangent at the point of contact. And then what I've done is I've sliced the circles uh, into quadrants. So if you want to slice something in ANSYS, you can go up here and hit create slice. And I'll click edit, right click edit just to show um, how to do that. But essentially what you do is you can slice by plane. So you pick your plane that you want to slice here by slice in base plane and your target bodies that you want to slice. And now I have also, I've also sliced this by cylinder. So what I've done is I've gone in here and create primitives and created a cylinder centered on the point of contact. And I've sliced the planes. And the reason why I did that is that I came in here, I'll show you later, but um, I sliced the contact area so that I could mesh it finer. And again, if you're slicing even surface bodies, you have to make sure that the surfaces are part of a part. So how to do that is you can come in here and select the surface bodies that you want to be part of your part, and you can click on them and hit shift and then and click on the bottom one to select all, and then you can right click. You right click and then left click on form new part. And what that does is it tells ANSYS that it's one, even though that the surface body has many different surface bodies, it's all one part. So ANSYS will conformally mesh this so that the nodes are shared between the surfaces. Now, if you don't do that, when you import the body, it will assume that it's different parts, and it will set up contact in between all of these line interfaces, I guess. And that's not what you want. You want to have one part. And so you can see here that part 3 is the bottom cylinder and part 2 is the top cylinder. And then And then now I'll show you how to set up the static structural model. So for this case, I'm actually going to run symmetry. So I only have a quarter of the circle or the top cylinder and the bottom cylinder modeled. So the first thing so in here, if you want to, you can actually right click and suppress a surface body in this model. So you can right click, suppress, and that will exclude that surface body from the analysis. So I have also set up my materials. So you can left click on the part, come down here under this tab, and you can select your material. So I have here an aluminum alloy that is a linear elastic material. And when you import an assembly or multiple parts in ANSYS, you will see this folder show up that says connections. And you'll also see that ANSYS there's a algorithm in ANSYS that will detect parts that are close to each other, and it will automatically set up a contact region. So if you click that contact region, you can actually see the bodies here, and the red will highlight the contact body, and the blue will highlight the contact region target body. And then over here, you'll get two different windows that you can scroll in. So you can see this is our contact body, and this is the target body. And then it will highlight, in this case, these are edges that are representing our contact surface. And so for this case, this is very important. Setting up your contact in ANSYS you can get very different results depending on how you choose how to set this up. So in this case, again, the theory is that the contact is frictionless. So there's an option here, and I've set it to frictionless. And so there'll be no shear stress on this surface due to friction. And the next thing is I've gone here and I've changed and under the advanced tab, and I've changed our formulation to normal Lagrange. So you can see here that you have program controlled. Uh, there's a couple other formulations: augmented Lagrange, pure penalty, MPC, beam, and I've selected normal Lagrange because what that essentially, I'll do another video on contact, but essentially what that does is it will not allow penetration between the two objects on the surface, which is what is actually occurring in our cylinder contact case. Now, there's reasons why you might let some penetration occur between the contact surfaces. Normal Lagrange is a computationally expensive contact model, and you can actually get something called chattering between the parts, where numerically, when ANSYS simulates the contact surface, it will sometimes the bodies will come into contact, and then they will separate, and then they'll come into contact, and it can be very hard to converge a normal Lagrange type contact. Now, in this case, because we're using symmetry, the model is constrained very well. So I haven't had issue running with the normal Lagrange. Next, I set up my mesh. So what I did is I clicked on those. Remember those surfaces that we created to essentially we're meshing this region with a finer mesh because that's where our contact is occurring. And now I set the radius of this cylinder larger than our contact width from the hand calc, so that I could capture the contact stress here accurately. And now for this case, I've picked a very small element size. It's only 2 mils or 0.002 inches. And based on our hand calc, for our case, I calculated a contact width of 15 mils, or a half contact width of a B of 15 mils. So I'm getting almost 8 elements. 1, 2, 3, 4, 5, 6, 7, 8. So this is kind of the edge where we predict the contact to occur. And this will allow, you want to make sure that if you're studying contact stress, that you have sufficient number of elements on either side of on your both your contact body and your target body. And then now for the boundary conditions, what I've done is, because this is symmetric analysis, we have on the bottom we have 2 lines of symmetry, and the top we have 1 line of symmetry on on this edge here, based on the x normal direction. And on the top, I've applied half the force of our hand calc because we're only modeling, even though it's a quarter circle, the applied force is only occurring on half the diameter. So you have to half the force. And then now I've set up for the boundary conditions. I've set this edge. I've set the displacement equal to 0. And so in ANSYS, if you're in a 2D analysis, there's a few ways that you can run symmetry. You can actually set the displacement by hand, the normal displacement on the edge to 0, and I've done that here. And then I've also set these faces, or these edges rather. Again, our normal vector here, represented by the plane of symmetry, is in the x direction. And I've set the x displacement to 0. And I'll talk about symmetry in another video in more detail, but there's other ways that you can set up symmetry. You can actually go into right-click, insert symmetry. And you can do cyclic symmetry. Even if you had a 2D model, you can set up symmetry, and ANSYS has other numerical methods that it will use if you tell it that there's symmetry there. If you're interested in, say, extracting vibrational modes, things like that, if you tell ANSYS and you use that symmetry condition, it has numerical methods to extract like the eigenvalues for the modes and things. But for our case, we're just going to use the displacements for symmetry. And then I've set up my stresses here. And then you can right click and hit run, and you will get the stress results. All right, yeah. In the next video, we're gonna post process these stress results and compare them to hand calcs. All right.